Hi everyone, in this video we are going to review Kepler's first law and talk about the elliptical orbits of planets. So we are here talking about ellipses. The important facts to know when talking about ellipses is that planets do not move in perfect circles around the sun. Planets actually have orbits that are shaped like ovals. We call these oval-shaped orbits ellipses. So you might be inclined to call it an oval-shaped ellipse, but the real vocabulary word that we are trying to learn this week in this video is the word ellipse. Ellipse is like a synonym for an oval. It's an oval shape. So if we look at this diagram here, we can see the sun in the diagram, and when we learn about ellipses, we're going to learn that the sun is actually not in the center of the solar system. It's a little bit off to the side of the orbit of the planet. So the sun is in the center but a little bit off to the side, and if we look at the orbit of the planet, or the path the planet takes around the sun, we can see here's our planet here, and here's the orbit. If we follow the path of the orbit and just take a look at the shape, we can see that the shape of the planet's orbit is more like an oval, or what we now like to call an ellipse. When we're talking about ellipses, we like to take a measurement of how much of an oval shape that ellipse is. The eccentricity is a number that describes how much of an oval an orbit is. So eccentricity is a number, and it describes how much of an oval the orbit is. If the eccentricity is equal to 0, the orbit is a perfect circle. The larger the eccentricity, the more of an oval the orbit is. Let's make a comparison chart to compare high eccentricity and low eccentricity orbits. So when we're talking about low eccentricity, the number for eccentricity, E is close to 0. E is for eccentricity, and the eccentricity is close to 0. And the shape is what we say more of a circle. If we're talking about how elliptical it is, if it's a lower eccentricity, we would say it's less elliptical. And here we'll draw an orbit of a planet. We'll draw the sun in the middle, and the orbit of this planet is going to be more like a circle. If we have high eccentricity, the number for eccentricity, E, is close to 1. Now, one important thing to know is that 1 is the highest value for eccentricity. An eccentricity of 1 is actually a flat line, so it's no more an oval at all, but actually a flat line. So 1 is the highest value for eccentricity. This will become important when we learn to calculate eccentricity, because it's a way to check your answer. If you end up with an eccentricity higher than 1, you know to go back and check your work. With a high eccentricity, we have the shape as more of an oval. And we would say it's more elliptical. If we were going to draw an orbit with a high eccentricity, I'd start by drawing my sun, and then I'm going to draw an oval for the path of the planet around the sun. All right, everyone, that's it for this video. We'll talk more later about how to calculate eccentricity.